Hey ProbStats kids, this is Dr. Callahan for week 7 Thursday. I hope you guys had a good week. One more day until fall break, so yay for that. Go ahead and pause the video and get started on your warm-up log. Just a friendly reminder, your warm-up log is due on week 9 Friday. Today it is week 7 Thursday. So we're getting a little bit closer and closer to that. Most of you guys are pretty prepared, so no doubt you'll get the 100 points. You should have 100 boxes completed. If not, go to week 1, Monday, all the way till now on the YouTube channel, and you should be able to have access to all the warm-up questions. And then the one that I'm really concerned about is your participation. Because of the hybrid model, I only see you guys like every other day. So the days when you're at home, it is critically important that you go ahead and check in with me by providing your initial to let me know that you are actually accessing the video itself, and make sure you are copying down the notes and moving on with the lessons in class. Here are the breakdowns of who wore what color on your problem of the day for question number 7. I saw this on Twitter. I thought was pretty interesting, and it says, what is the most effective mask? No doubt the KN95 one is the most effective. It's also not the most comfortable one, but it's the most effective. Surgical mask is pretty good. I thought it was interesting because the majority of us wear the sponge mask, and it says fashion use, and I don't think anybody's wearing that for fashion use. But look at the stark, small, minuscule percentages of protection that it offers. And given the fact that we're talking about percentages in probability and statistics, I thought that was particularly interesting. The cloth masks are okay. I have one, but they're not as effective. And so it's interesting. It says it protects 0% against viruses. Well, I'm pretty sure COVID is a virus. So yeah, interesting to see how this actually works. Okay, so on week 7, Wednesday, you guys, we started section 11.6. It was a brand new section. You guys had homeworks, I believe, in number 1 to 6. And so let me go ahead and share with you guys the answers to those. And remember, you have to do these. These are accessible on your Google Doc. And if you're not sure what the Google Doc is, on your white packet, on the very bottom of each page, the footer, I have 2 links. One link is to the YouTube video, and the second link is to the Google Doc. So you should have access to both. Here are your answers. Yesterday we talked about complements, which basically means not. So yesterday we talked about the probability of not something occurring, and that was our topic. All right, so today we're going to continue with that section, and we're going to get started off with the following example. Go ahead and take a look at the breakdown. It's 11.6 continued events involving not and or odds. We're going to go over objective number 12 today, which is on page 22. You will have a quiz the following day. So if I have you on virtual learning day that day, make sure you check onto MS Team and then do the assessment there. Go ahead and turn to page 11. All right, so let's go ahead and take a look at this. So if A and B are mutually exclusive events, then probability of A or B is equal to the probability of A plus the probability of B. Using the set notation, P of A union, remember that little symbol, union B, which is equal to P of A or P of A plus P of B. which means you add them. Let's go ahead and take a look at an example. Take a look at example 4. With example 4, it says one card is selected from a deck of cards. What is the probability of selecting a king or a queen? Keyword here is or, which means you add. Well, let's think about that. So the probability of a king or queen is going to equal to the probability of a king plus the probability of a queen. And remember, with a probability, it always needs to be in a fraction. So 2 fractions, you know the total of the deck of cards is 52. So how many kings are there in a deck of cards? Now, just as a quick little summary, remember there are 4 suites. You have clubs, heart, spades, and diamonds. With each of these numbers, you have, or cards, you have 1 to 10, jack, queen, and king. So if you take a look at it, there's actually going to be a queen in all 4. So there are 4 queens and 4 kings. So I have a common denominator, which is awesome because I don't need to do any fractions then. 8 over 52, reduce it by 2, you get a 4 over 26, reduce it by 2 again, 2 over 13. Make sure you put this in a decimal and a percent. All right, let's go on to example 5. Go ahead and read example 5. So it says, in a group of 25 baboons, so this is the total number of monkeys, 18 enjoys grooming their neighbors, 16 enjoys screeching wildly, while 10 enjoys grooming the neighbors and, keywords, and screeching wildly, so both. If one baboon is selected at random from the group, find the probability that it enjoys grooming its neighbor or screeching loudly. Now with this problem, you have a new formula, which is right here. So it's a probability of A union B is equal to the probability of A plus the probability of B minus the probability of A and B. And the A and B here is both. So that is the monkeys enjoying grooming and screeching. So that would be both. So let's put this into perspective. So the number of monkeys that enjoys doing both is 10. The number of monkeys that just enjoys screeching, as for screeching, is 16. And the number of monkeys that enjoys grooming their neighbor, G for grooming, is going to be 18. So those are my numbers. So let's go ahead and put this in. Probability of the monkeys grooming or screeching is equal to the probability of the monkeys grooming plus the probability of the monkeys screeching minus the probability of the monkeys grooming and screeching. So we're going to have 18 plus 16 minus 10 divided by 25 because there are 25 monkeys total. And lucky for us, we have common denominators again, so that is good. So what is 18 plus 16 minus 10? Yep, it is 24 over 25. Make sure you guys go ahead and convert that to a decimal and then convert it to a percentage. All right, let's go on to page 22, which is on objective 12. I'm gonna have you guys go ahead and practice with this on your own. So pause the video. All right, let's go over this together. You are dealt one card from a standard of 52 deck of cards. So you know that this is going to be the denominator because that's the total number of cards. Find the probability that you were able to dealt a 7 or, which means plus, a red card. Now remember, how many red cards are there in a deck? Well, half of them, so 26. And then how many cards are going to be a number 7? Now remember, there are 4 suites. In each of those suites, you have numbers 1 to 10. So there's going to be a number of 7 in clubs, a 7 in spades, a 7 in diamonds, and a 7 in hearts. So how many 7s are there? 1, 2, 3, 4. So there will be 4 7s. So let's set this up. Probability of a 7 or red card is going to equal to the probability of a 7 plus the probability of a red card. So I will have 7s, there are 4 out of 52. Red cards are 26 out of 52. I have my common denominator, so let's do 26 plus 4, which is a 30. Go ahead and reduce this by 3, or excuse me, reduce it by 2. You get a 15 over 26. And that's as far as we can go. Make sure you convert this to a decimal. And then convert it to a percentage. Okay, so for B, what is the probability that you will find a heart or a face card? Now, remember with hearts is going to be in one of the suites, okay? And in a suite, there are 13 cards. So there are 13 hearts. A face card is either a jack, queen, or king. And remember, there are 4 jacks in each of the suites, 1 in clubs, 1 in spades, 1 in club, 1 in spades, 1 in diamond, 1 in hearts. So there are 4. Same thing with queen, same thing with king. So 4 times 4, sorry, 4 times 3 is going to be 12 face cards. Now that I have these 2 numbers, 13 hearts and 12 face cards, I can go ahead and proceed forward with my equation by setting it up with probability of a heart or face card is going to equal to the probability of a heart plus the probability of a face card in fractions, because probability means fractions. So 13 over 52 plus 12 over 52, which is 25 over 52. And that is your answer. Make sure you convert it to a decimal and convert it to a percentage. All right, you guys, that is pretty much it. I will recommend that you go on to the Google Doc for week 7 Thursday, because there are a few practices that I would like you guys to do. One of which is your homework, which is right here. Make sure you guys do that. Another thing is this quizzes that you guys can go ahead and practice. And another one is to go ahead and watch this video right here that is on probability with not mutually exclusive examples. Keep in mind, you guys will have an assessment tomorrow, so make sure you check MST. And before I leave you guys today, I want you guys to make sure you're doing the exit ticket. So somewhere along your white packet, go ahead and answer the following question. So it says, after today's lesson, do you have any lingering questions? Perhaps you have some tough questions you really want to ask the teacher. Write them down. Have a good evening. I'll see you guys next time. Take care.